I hope that I have made it abundantly clear throughout these videos that the success in mathematics comes from the fact that all numbers are connected, and that once children can see these connections, absorb them and work with them, maths is easy. So I just wanted to reiterate the importance of not doing work in isolation. For example, if you want to do 4 times 17 and the child gets into a fuzz, 4 times 17 is 2 times what? Questions like that. And if the child doesn't understand, use your pebbles to see. How does even 4 relate to even 2? I always say, what does even 4 say to even 2? I make them into people. I anthropomorphise my pebbles. So the children might say, oh, you're smaller than me. Yes, what does even 2 say to even 4? You're bigger than me. And then, of course, I want more. I want the nature of the relationship. So what I'm after is that even 2 will say to even 4, you're twice as big as me. And even 4 will say to even 2, you're half my size. So if I've got 4 lots of something, that's twice as much as 2 lots of something. If I've got 2 lots of something, that's half as much as if I've got 4 lots of something. These understandings, which are not normally focused on, are the core aspects of making maths easy. So then again, I look at an even 8, and even 4 can have the same conversation with even 8, and even 3, and even 6, and even 12. And perhaps odd 9 can hop in there. We can have odd 3 saying to odd 9, you're 3 times as big as me. And we can start understanding what that means. This is leading us into fractions, because if odd 3 says to odd 9, if odd 3 recognises that he can fit 3 times into odd 9, or from our number chart, a multiply chart, 3 3s pulls down a 9. So odd 3 can say to odd 9, you're 3 times as big as me. And then we want the reverse, which is you are 1/3 of me. So when we start writing them, we can see 3 times and 1/3. We can see a relationship in the numbers, which is quite hard for some children initially. So I focus on the reality before I start writing numbers. So once the children have absorbed this, we can say 9, odd 9, is 3 lots of 3. We can say that 3 is 1 part out of 3, 1 part out of 3 parts of 9. Look where we're going later on. And when we start doing this work later on, this is what makes it understandable, especially for children who are neurodiverse, because at school just doing this stuff becomes a nightmare. So this connectivity and relationship all the time, whenever you're working with any number or numbers, is really important. What can you see? What can you see? What relationship can you see? I'm asking the children all the time. Now say, for example, even 2. Even 2, we're always talking about family, 2, 4, 8. This leads us into powers and roots, because we've got even 2 multiplied by itself makes even 4. Eventually we understand that that's 2 squared. Multiplied by 2 is even 8. That's 2 to the power of 3. And once they've been doing this jumping, this mirror game jumping, you can give the even 2 the power in his legs. He's doing all the jumping. You can make up stories and you can make this creation of powers so simple. Odd 9 is the next power of odd 3 because there's 3 lots of 3 in the odd 9. So odd 9 is 3 to the power of 2. 3 raised up to the next power, multiplied by himself, is raising him up to the next power. I think this is a lovely way to introduce powers and roots.